In this video, we're going to cover the derivatives of the 6 standard trig functions. I've listed all 6 right here. I'm not going to derive most of them. You can either look in your book or you can look online to find them. Some of the proofs are just kind of long and annoying, and it's not really what I want to focus on right here. However, I do want to show you how to use these rules combined with things like the product and the quotient rule. And I'm going to start by deriving the tangent rule here. And the way I'm going to do that is I'm going to say, okay, I want to take the derivative of tangent x. Well, you should know from trig class that tangent is the same as sine x over cosine x. So I'm dividing these two trig functions. So then I would use the quotient rule, which says the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And then I will use the two rules, derivative of sine and cosine, which I gave you up here. And I know I have improved them, but we'll accept them at least at this point in time. The derivative of sine is cosine, so I have cosine x times cosine x. And then the derivative of cosine x is a negative sine. And if you simplify the top, it's going to be cosine squared x plus sine squared x. And if you know no other trig identity at all, you should know that sine squared plus cosine squared is 1. If you don't know that one, definitely learn it. There's also a couple others that you should know in this class, but we're going to have then 1 over cosine squared. And this would be a perfectly valid answer, but if you see up here, we don't write it that way. 1 over cosine is the same as secant, and so here we get secant squared. That's the derivative of tangent. And this process would work to find the derivative of secant, the derivative of cosecant, the derivative of cotangent. However, this would not work for sine or cosine. Those are the more basic ones, and we need a special limit trick to work those out, which we will see in a different video. So I'll leave those for now. However, we can use this to find other complicated derivatives. So, for example, what if I wanted to find the derivative of f of x is, how about cosine x over sine x plus tangent x? So this is none of the simple 6 trig functions. This is a more complicated one. But we can still use things like the quotient rule to get our answer. And so, okay, we're going to go ahead and take our derivative here. By the quotient rule, the derivative of the top times the bottom minus, oops, not derivative there, minus the top times the derivative of the bottom all over the bottom squared. And then derivative of cosine is negative sine times sine plus tangent minus cosine. And then the derivative here, it's going to be derivative of sine is cosine, and the derivative of tangent is secant squared. All over that mess here. And then what are we going to do? We'll see. We distribute in there. We'd have a negative sine squared x minus sine x tangent x minus cosine squared x. And then cosine and secant are reciprocal, so 1 cosine, 1 secant cancel. We're going to be left with just minus secant x. And then we have a minus sine squared and a minus cosine squared. That's going to be a minus 1. And And this is probably the best we can do. I mean, we could try messing around with more identities, but I don't really think it's worth it here. One thing that you're going to see as these derivatives get more and more complicated, you want to be careful with your algebra, because if you use an algebra that's actually incorrect, then all your work is just going to give you the wrong answer there. So you want to really be cautious with that and do what you can. And if you're not sure if you can simplify something, it's probably better just to not simplify it. So this is how we're going to use the trig derivatives to find more complicated things. We could also have something like a combination here. Find the derivative of, let's see, f of x is e to the x sine x over x squared plus 1. So again, we have this mix of different functions. We start with the fact that we have a fraction, so we use quotient rule. That's going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And then notice that the top part is e to the x sine x. We take the derivative of that. Well, in order to take the derivative of that top, we need to use the product rule because it's two things multiplied. So let me use a different color here. The derivative of e to the x sine x is the derivative of the first times the second plus the first times the derivative of the second. And then we still have everything else. And you see I'm getting a little lazy here. So then when I start working things out here, the derivative of e to the x is e to the x. Derivative of sine x is cosine x. All of this is times x squared plus 1 minus e to the x sine x. And we have the derivative of x squared plus 1 is going to be 2x. And then we have all over x squared plus 1 squared. And again, you could try playing around with that. Maybe you could simplify something there. But it's definitely a mess, and it's not going to be great no matter what you do. So I'm fine with leaving it like that for now. So you see, you can combine the previous power rule and exponential rule with the trig functions and the product and quotient, all that good stuff. You can get all of it in one problem. So as you see, as we get to the different chapter sections, we're going to be doing more and more complicated derivatives. And just imagine if you try to do the limit definition here for this derivative, it'd be insane. So these new rules allow us to handle more and more complicated situations.